All right, in section 6.7, we are looking at how to find the inverse of a relation or function. It says if a relation pairs element A of its domain to element B of its range, the inverse relation will pair B with A. In other words, if we have an ordered pair like this, our inverse is going to switch those x and y's around. It says if both the relation and its inverse are functions, we call them inverse functions. So it is possible to have an inverse that is not a function. It says the diagram here shows relation R. In this we have our domain 1.2, 1.4, 1.6, and 1.9. The arrows show us how it maps onto the range. In other words, 1.1 is paired with 1, 1.4 is paired with 1. So we could look at that as two separate ordered pairs. 1.6 is paired with a 2, and 1.9 is also paired with a 2. Okay? That is a function. Every x value is paired with a single y value. In other words, none of these x coordinates are repeated at all where they're paired with a different y value. But if we look at the inverse of that, where we switch our x and y's around, now our range from here turns into the domain of the inverse. And our domain here becomes the range of our inverse. So now if we look at our ordered pairs, we are saying 1 is paired with 1.2, but it is also paired with 1.4. And that is where it fails to be a function. We cannot have the same x value being paired with two different y values. Same with the 2 is paired with two different numbers. All right, so this is not a function. This one is a function. All right, our first question here. It says, what is the inverse of the relation S? A relation, again, is just a pairing of two numbers. So we've put those in a T-chart format. If we want to find the inverse of S, we can note that like that. S with a little -1 power means the inverse of it. And all we have to do is switch our x and y values. So in the first ordered pair, we had 0, -1. Now we're going to have -1, 0. Here we had 2, 0. Now it's going to turn into 0, 2. 3, 2 becomes 2, 3. And 4, 3 becomes 3, 4. So we're just reversing our x and y's. All right, so we're going to look at the graphs here. For relation S, we have the points plotted here. Those were the ones in my original T-chart. Now if we look at the points we found in our new one here, our inverse function, we have -1, 0. We have 0, 2. We have 2, 3. And we have 3, 4. And if you compare them, we are looking at basically the graphs are going to be reflections over the line y equals x. So if we graphed y equals x, so x and y coordinates match, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. If we graphed that line and compared our two functions here, we'd see that they are just reflections over that line. In other words, this point here was 0, -1, and this point here is -1, 0. Just a reflection over that line from here to here. So what I want you to get from this is that when you are graphing an inverse function, it will be a reflection over that y equals x line, and our x and y coordinates are just going to be switched. To describe an equation for the inverse of a relation or function, we need to switch the x and the y's, and then we're going to solve for y. That is how we are going to determine our new inverse function. Okay, so switch the x and y's, and then solve for your new y. So in our first example here, our original function is y equals x squared minus 1. To switch our x and y's, instead of y, we're going to write x, and instead of x, we're going to write y. Everything else stays the same. And now we have to solve for this new y. Okay, so the first step I would do would be to add the 1 to the other side. And then to undo the square, I'm going to square root. And remember, we always have plus minus in front of our square root. So this is going to be the inverse of my original one. Okay, let's try one more of those. Starting with y equals 2x plus 8, we're going to switch our x and y's. So now I have the equation x equals 2y plus 8. I'm going to subtract the 8 to solve for our y, and then we're going to divide out the 2. So we have y equals 1/2 x minus 4. Again, this is the inverse of what we started with. All right, the last thing we're going to do is we're going to look at the graphs of those two. We've said that a function and its inverse should just be reflections over that line y equals x. So we are going to start out graphing our parabola. Y equals x squared minus 1. This is a parabola that has been shifted down 1. All right, so starting with our basic parabola points, 0, 0, 1, 1, 2, 4, and their reflections, we need to shift those down 1. So we are going to have a point here. I'll use x's for these. We're just shifting everything down 1. Okay? I'm going to clean that up for a second here. All right, so this is my original function. And then we're going to graph the inverse. Now, this is a square root graph. We've talked about square root graphs. We know they have that endpoint and then that arch. The plus and minus in front is actually giving you 2 of them. So we're going to think of this as y equals positive the square root of x plus 1 and y equals negative the square root of x plus 1. We're going to graph both of those. And for these, we have a square root graph that has been shifted to the left one. All right, so our square root graphs, normally our points for our square root graphs 0, 1, 4, 9. Square rooting, we get 0, 1, 2, and 3. Now we have to shift those left 1. So the 0, 0 is going to move here, left 1. 1, 1 is going to shift left 1. 4, 2, shifting left 1. And 9, 3, shifting left 1. That is the positive version of it. And now the negative here just means that we have reflected over the x-axis. So we're going to take those same points and we're going to reflect them over the x-axis to get the other half of our graph. All right, so I want you to picture graphing that line y equals x. All right, we have just the reflection over that line to go from the blue graph to the green graph. Now remember our vertical line test that we had to tell if something was a function. Would our blue, the original y equals x squared minus 1, would that pass a vertical line test? And I would say yes. Since it passes a vertical line test, this is a function. If I look at the green one, does it pass the vertical line test? Since it doesn't, we would say y equals the plus minus square root of x plus 1 is not a function. It still is the inverse of the original one, but it doesn't give us a function on its own. All right, the last one we're going to look at. We were given y equals 2x plus 8, in our previous example, and we found the inverse. So the inverse of it, we came up with y equals 1/2 x minus 4. So we're going to graph both of those. These are both in slope-intercept form, so I'm going to just graph them with those techniques. Our first one, we have a y-intercept of 8 and a slope of 2. So we're going to go rise 2, run 1. We can also go down 2 and back 1 since we're kind of out of our grid paper here. All right, so that is my original function. Okay, and then I'm going to draw my line in. Try to hit your dots. All right, second one, we are starting at -4, and we are doing a slope of 1/2. So rise 1, run 2. Again, I'm going to move down and back 2, down 1, back 2. And draw that in. All right, and again, if you had folded your paper along that line y equals x, you would see that this is just a reflection of that. Okay? In this case, both of those graphs would be functions because they both pass a vertical line test. All right, so for homework, you guys are going to do page 410, questions 9 through 29 odd, 75 to 81, and 85 to 88. We will finish up this section tomorrow.